The topic of this experiment was the effect of temperature on the speed and volume of sound. The question was, how does temperature affect the speed and volume of sound? Sound is anything that can be heard. Sound travels in the form of sound waves. In the literature review, sound waves are affected by many factors as they travel in various channels and mediums. These mediums can either be solids, liquids, or gases. Research showed that sound travels faster in mediums with higher elastic properties than in lower elastic properties. The elasticity of solids are more than liquids and gases. Sound also travels fastest in solids because the molecules in solids are closely packed. It is also known that atoms and molecules in less dense objects are less compact, so the transfer of sound energy is slower. Aside from elasticity and density, temperature is one factor that can impact sound. Heat is a form of kinetic energy. Molecules at a higher temperature have more energy. The hypothesis in this experiment was if the sound waves were produced in different water temperatures, then the sound produced in the hot water temperature will be faster and louder. The independent variable was the temperature of the water, which is 5 degrees Celsius, 20 degrees Celsius, and 80 degrees Celsius. The dependent variable was the speed and volume of sound. The constants of this experiment were the same: cylinders, thermometers, rubber mallet, tuning fork, sound level meter, same amount of water, and the same person tapping the tuning fork. These were also the materials for this experiment. The procedure. Before conducting the experiment, the materials were prepared. The graduated cylinders were then labeled with cold temperature, room temperature, and hot temperature. 70 milliliters of cold water at 5 degrees Celsius was then poured into a graduated cylinder labeled with cold temperature. Then the sound level meter was positioned close to the rim of the graduated cylinder. The tuning fork was then struck with a rubber mallet and holding it by the rim of the graduated cylinder with cold water temperature, the decibel measurements were recorded. The same process was repeated with 70 milliliters of room water temperature at 20 degrees Celsius and 70 milliliters of hot water temperature at 8 degrees Celsius. The experiment was repeated 3 times. The data collected was used to calculate the speed of the sound waves. The results. The hot water temperature produced the loudest sound and highest pitched sound in this experiment. The pitch of the sound was directly dependent on the frequency. By using a sound level meter, it showed that the hot water produced the highest frequency. These are the data collected and recorded. Since the wave speeds are dependent on the frequency, the hot water produced the fastest sound, and the temperature of the water affected the speed and volume of sound. The graph shows the average wave speed of cold, room, and hot water temperatures. In this experiment, it was determined that the temperature affects the speed of sound. The hot water cylinder produced the loudest and highest pitched sound. The pitch was dependent on the frequency, and the sound waves were directly dependent on frequency. The purpose of this experiment was to understand how temperature impacts sound and what were the factors and mediums involved, and to explore a relationship between temperature and sound waves, which is important to people for communication and awareness of surroundings for safety. Understanding how temperature affects sound is an important and powerful indicator of what is happening in our environment. The hypothesis of this experiment was that if the sound waves were produced in different water temperatures, then the sound produced in the hot water would be faster. The results supported the hypothesis. The wave speeds directly depend on frequency. Therefore, the higher the temperature of the water, the faster the speed of sound. Recommendation for future study is to conduct the experiment in a soundproof environment and to use the sound meter app because some studies say they are more reliable.